Hello, warm welcome to everyone joining. Thank you for being here. Go ahead and get yourself ready with a notebook. You can grab a pencil or a pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today, for my Calc BC students, or my Calculus 2 students, we're going to continue some AP Calc recap. Okay, some concepts that you should have learned in Calc 1 that you're for sure going to use in Calc 2 or Calc BC. Give these two problems a try. They're referring to the IVT and the MVT. Maybe take 10 minutes total. I think you can do it faster than that. Hopefully 7 or 8. But time's not the most important factor right now. The recall of how to do these problems is what's most important. So if you can figure it out, that's what I care about more. We can work on the speed. But first we need to see, can you figure it out? Don't give up. Okay, you can pause the video, give yourself some time. Then when you're ready, unpause the video, come on back. See what we did here. Okay, number 1. Determine if the mean value theorem, so this one's going to refer to the MVT, applies to f of x equals 7 minus 8 over x plus 2 on the interval 1 to 4. If it applies, find the value of c guaranteed by the theorem. So they want you to find the value of c, which is an x value. And this x value is a result of the mean value theorem. The condition for the mean value theorem to apply is that the function has to be differentiable on the open interval from a to b. So in this case, from 1 to 4, not inclusive. The function does have a domain restriction, but you might notice that this is simply at x equals -2, which is not a problem because we're going from 1 to 4. So yes, it applies. And how do we use it? If it applies, then we should apply it. Find the value of c guaranteed by the theorem. Now what the theorem says, you should go back and check this if you didn't already know, basically says that the average slope on the interval, so somewhere from a to b, the average slope there is equal to the exact slope at some point on the interval. And they call this value c. Okay, so how do we find average slope? We do the simple, rise over run, y2 minus y1 over x2 minus x1. Did I say that right? y2 minus y1 over x2 minus x1. See what that gives us. Well, if you plug in 4, you're going to get 7 minus 8 over 6 minus 7 minus 8 over 3. And if you notice, 8 over 3 is just double of 8 over 6. Notice that. So when I distribute this negative, I end up with positive 8 over 3, which is double of the 8 over 6, leaving me with 8 over 6. And this is all over 3. And here we have 8 over 18, which of course we can reduce by 2. And we get 4 nines. Kind of looks like a 9 on top. Let me fix that. That's better. So that's the average slope. We need to find when this average slope is equal to the exact slope, which means we need to take a derivative. And if we think about the function as 7 minus 8 times x plus 2 to the -1, then the derivative would simply take away the 7. And we'd have 8 times x plus 2 to the negative 2, or 8 over x plus 2 squared. Great. Now, if we set this equal to the average slope, we can make a proportion, and we can solve the following equation. 4 times x plus 2 squared equals 72. Divide both sides by 4, and get that x plus 2 squared equals 18. So x plus 2 is the square root of 18, but we have to consider the plus and minus case. I'll talk about that in a second. And of course, you can simplify the root if you'd like, and subtract 2, please. Negative 2 plus or minus 3 root 2. Now, root 2, you don't have to know this. It's approximately 1.41. So 3 of those is simply approximately 4.23. And the reason why I want to get close to that is so that I can show that the negative and positive case yield some important distinguished results here. If we have negative 2 plus 4.23 compared to negative 2 minus 4.23, this value is definitely not in the interval that we're using from 1 to 4. So we're going to exclude that value, but we had to consider it. It's just not valid. Here we're going to get 2.23, which is totally on the interval from 1 to 4. So that is our value of C. What it means is that at 2.23 approximately, the slope of the function is the exact same slope as the average slope from 1 to 4. Okay, great. Let's move on to number 2. We're going to use the intermediate value theorem for this. It kind of demonstrates a really beautiful idea and principle behind solving equations and also finding their solutions, especially when you're graphing. When two things are equal, what does it really mean? Not to get too philosophical, but when two things are equal, it means their difference is 0. In fact, we say there's no difference. They're the same. They're equal. Which means that if you subtract everything, or rather move everything to one side, it's easier to see when things are equal to 0. So we're going to test the left and right endpoint of this interval. And we're going to see if we can prove that because this function is continuous, which means it's smoothly going through the values, it's a polynomial, which is continuous, we can say that the value that it hits at -1, oops, that's not a negative one, at -1, and the value that it hits at +1 creates a boundary range of values. It has to smoothly get from this spot to this spot. So what we can do now is we can plug in -1. Of course, if we square -1, we still get +1, but it's times a -1/3. So we have -1 minus a third plus 1, and that's a negative value. Why does that help us? Well, if we can see that we get a positive value when x equals +1, then we can confirm that the values had to go through 0 at some point. That's what the IVT allows us to conclude. So let's plug in +1. We're going to get 1 to the 5th minus 1/3, again, 1 squared, plus 1. And now this is going to give us +1 minus 1/3 plus 1, which equals 5/3. That's positive. So what do we conclude? We conclude that somewhere along the way, from -1 to 1, the y values had to cross 0. Yeah. We could say f of c equals 0 for some value between -1 and 1. Okay, so the conditions for these theorems are important. These theorems only apply if we've checked that it's either differentiable or continuous. Now, how do we know which one's which? The IVT is used whenever we're looking for a point, or like a solution to the original function. Those are just y values. So y values go with the original function, and the IVT goes with the original function. The mean value theorem says stuff about slopes. So we need it to be differentiable. You want to check for any domain restrictions, because those can hold you back and make the theorems not apply. Alright, I think that's a healthy recap. Enough blab out of me. I'll see you guys next time.